Welcome back. So today we will be working on one of my favorite things ever, a third-person character controller. By the end of the tutorial, you'll be able to build this exact thing that I've got going on right here that you're seeing on the screen right now. So if you're interested in this, stay tuned. Alright folks, welcome back. Today we're going to try and quickly set up a third-person character controller. So first things first, create an empty game object. We'll call it player. Let's drop a capsule in here and we'll throw it in like that. Where is this player at? He's under the map, so let me at least bring him up here. There he is. There's our boy. We're going to call him Bob, or maybe, yeah, actually Bob's good. And then we actually want to add some sort of a way to see which way he's facing. So there you go, Bob. We're going to give you a big ass nose right out. Oh wait, that's not the right axis. So in Unity, the forward axis is actually the Z axis. So if you look up here at the Z, the blue arrow. So his nose is definitely not right. Let's just reset that real quick. And we will work on his nose. There we go. And boom, there's Bob. Bob's got a big nose. You know what they say about people with big noses? They can smell really good. Alright, so we'll remove this capsule collider because we really don't care about that. And I'm going to rename this. This is going to be the mesh. And so I set up this player model in a way that we can add a character controller here. And the character controller itself doesn't depend on the mesh. So this mesh we can swap out later for the Master Chief. And yeah, I think we're pretty much good to go. So the next thing is I've actually installed Cinemachine. So if you're not familiar with Cinemachine, cool, me either, never used it before, but it's supposed to be really helpful for controlling cameras. And so we're going to try it out actually. Go back over to hierarchy. And when I installed it, it added this nice toolbar up here. I did look at this a little bit, so I do want to create a free look camera. We're going to call this the player camera. Wow, what the heck was that camera? Player camera. And let's see, we want to, if you look at all these settings, we want it to follow and look at our player. So we'll just drag that into there. And then if you look in the game view, yeah, look at that. He's really close. So we have to modify these rigs. So if you look, there are these kind of red circles in the scene view here. And what we want to do is we'll just put this up at like 8 looks too high. We'll go -1 for the ground. That looks too low, so maybe -0.5. Put this at 4, sure. And then the radius controls like how far out the camera is. So we'll go with like 12. And then we'll just say 8 and 8. And so what's going on is the Cinemachine will actually take care of, you know, whether you're kind of going up or down. It'll take care of making sure that it's always looking at the player, and it'll kind of follow this track. So it has these rigs is what they call it. And it also, if you look at this, there's something going on with our main camera, this little red thing. So if you click on that, Cinemachine has added a Cinemachine brain to the camera. And so that makes your camera super smart, and it'll take over your computer and probably kill you in your sleep. Not really. I don't know what it does. Like I said, I'm new to Cinemachine, so I don't really know. Whatever. So let's take a look at our character controller. This height is 2 meters, radius is 0.5. Yep, that looks good to me. I don't think it really matters, so we'll just go with it. And then what we want to do is I have actually started setting up a little systems folder here. So inside of ROL, Ring of Light, I've created a systems folder, and inside that I have a player. So this will be part of my player system. I'm going to add this third-person character controller onto the player. Now right now there's nothing, like the script is completely empty. So we're going to go in and code this. We're doing this real time here, so if I get lost, I do have a little code that I've written before, and we'll try and use that. So first things first, I know we're going to be doing some stuff in the update method, so we'll start off with that. I know we're also going to want, to control his speed, which will be a float variable, not a float, but a float. And I'll go ahead and set this to something like, let's do something high, like 20. I gotta be able to run across Bud Gulch as fast as I can, because I am a marathon runner. What else are we gonna need? We're gonna want to control his, probably his rotation, like how fast he can turn. So we'll call it turn speed, and we'll just put that at like 1. I don't really know. And of course I'm creating my type here as a goofball. And I know we're going to want to add in some sort of lerp or damping, so we'll call this like turn damper. Sure, whatever. Doesn't really matter what we call it. And that'll be good for that. All right, so the very first thing, we are going to want to get the horizontal and vertical input, so from the WASD keys. So it would be, what is it, key down or get? No, get access, that's what it is. So I believe it's all caps, could be wrong. We'll have to find out. And then we're just going to copy that real quick. We're going to grab the vertical. And boom, there we go. So that's just grabbing our directional keys. We'll add in a little thing here. Directional keys. All right, now we actually want to compute the direction. And so that will be the direction we're going to be walking in. So we'll call it walk direction, and we want it to be a vector, or do we? Let's see, we want it to point in the direction of the horizontal and vertical axes. This might actually be a, let's do like this, equiturnin from Euler. That seems to make sense to me. New vector. Okay, so what we're doing here is we want to essentially combine this horizontal and vertical axis to get the actual direction we're walking. So the whole point here is to just put these two things into a vector. So I don't think the rotation makes sense. We actually need just a vector here. And so we want to have the horizontal, which will be the A and D keys along like the x-axis. We're not doing anything on the y-axis, so we just leave that there. There we go, horizontal, vertical. This will give us the direction that we're walking in. If I could spell, then it would be direction, but for now it's direction. You know how it is. Okay, and we also are going to need a reference to our character controller, of course. So character controller, we'll just call this controller, not with a big O though, just a little O. And what we're going to do is in our update method, right, so we're going to actually move our character, and we want to move him our speed. Actually, we'll go with direction first. So the direction that he's walking in times the speed he's walking at, and we always use time at delta time, or I always do. Okay, so let's save this, and we will now go back into Unity, let it compile its thing, do its thing here. Play the Jeopardy music going in my head right now. Okay, click play, and let's see what happens here. All right, so the camera is working pretty much as expected, except it seems inverted for me. So that's a little bit weird. We didn't assign our character controller here, so it doesn't know what to do when we want to move forward. I'm going to go ahead and fix this camera. So I actually want the Y to be inverted and the X to not be inverted. And that's just a personal preference for me. You do not have to do that, but it was just kind of awkward. It was not spinning the way I thought it would. All right, so I click forward, I click my keys here. Yeah, this is working, except it's not following in the direction that I'm looking. Also, you can see I'm floating, so there's no gravity. Let's see if I go up here. Yep, no gravity. So lots of things we need to fix here. So let's pop back over into our code. All right, so how do we get that direction? One thing we should do, we should also check that the walking direction, we need to make sure that there's actually a value here. So if it's greater than or equal to, we'll just say 0.1 float. And then what we're going to do is we will actually have him face the direction that he's going. So we'll call this like the target direction. So that's the direction we want him to face. And we'll be using the A10 function, A10-2 actually. So the idea here is we take the walking direction in the X, the walking direction in the Z there, and we need to change this to an angle. So we'll use radians 2 degrees. Yeah, we want it to be degrees. And this will actually give us the target direction that we want to walk based on the input, so our WASD keys. This will actually give us, I guess it's an angle, so we'll just say it's our target angle here. Not a big N. There we go, target angle. And we'll take this angle, and what we need to do next is actually sort of lerp the target angle from our existing angle right now. So we will, we'll call this move direction, and we will use, not turn damper, it would be, I can't remember if it's vector or damp, smooth damp. Is that right? Smooth time, max speed. Yeah, okay, that looks close. There should be another damp. Is it quaternion? Nope. Okay, so it was vector. Vector 3, smooth damp, and we're going to go from our current, which would be our walking. Our walking direction. We want to go to our target angle, and this would be, yeah, actually that looks right. Our target angle, our current velocity. So it's just a ref value. So we'll just create one. We'll just set up one up here, a private variable. This would be, what is it called here? Smooth time. Smooth time, sure. And so it needs it as passed in as a reference, so I can make some updates there. And then there was something about speed. Oh wait, that was smooth time. It was supposed to be velocity. Whoops, we'll just rename that to, okay, we'll call it turn velocity. And then the smooth time, so we're going to use our turn speed for that. Although we might need this turn damper instead. Not quite sure. Okay, so our turn angle, we need, okay, so it's complaining about this and this, smooth damp, floats. Oh, this is supposed to be a vector 3. Wow, I wish I could read. That would be nice. Okay, and the last thing is this turn angle. It's actually expecting a vector. So what we need to do is not use this. This doesn't look right, so I should be putting in my current angle. So we're actually going to, I think this, is it in math? Smooth damp, this is what I want, smooth damp angle. Okay, goodness gracious. Excuse me, folks, I do not know where things are because I'm a noob. Welcome to noob land. Okay, so our current angle, our target angle, this is what we're actually wanting here. Turn velocity, yeah, so it is wanting a float. This makes much more sense here. Turn speed. And we're actually going to use turn damper for that. All right. And then what we need is, so we need a float here. It's our current direction. So that would be our current rotation. And we want it to be along the Y because our guy is going to be rotating along the Y-axis, rotating, spinning the circle. And we're going to change this to angle. And boom. There we go. And so this will actually give us our current direction, the target direction, so whichever way we're kind of walking towards. This will actually turn the player model to face the angle that we want, or at least it will once we set this up here. So now we just need to apply our own rotation here, transform.rotation. We will have to set up our weather angles. We don't care about any of that. We just want the Y direction. And boom. Okay, let's go check that out now in the editor and see what we can see here. It'll reload the script. And all right, let's just double check that the player's all set up. This all looks good to me. Click play. So now if I turn, so he's trying to turn. We've got some sort of issue going on here. So as I'm pressing my A and my D keys, he kind of turns a little bit. As he's just turning really slowly. Now something's bringing him back, so we do have some issue. Let's go take a look at our code. Okay. Yes, so we're still moving with this walking direction here. We're not actually using our rotation. What we really need to do is let's go ahead and move this inside of here. And let's create a new variable. This will be our we'll call this move direction. And I think I might go back and rename this walking direction to something else. And essentially what we want to do is we have this rotation that we're moving at, and we need to multiply it by our forward vector. So in Unity, the forward vector is going to be the Z direction, and we want to essentially turn our player towards this move direction. So we want its forward to kind of look at the direction that we're moving in. And so to do that, we are going to use a quaternion, got the Euler angles. So we want it to be the Y, and we want to use this target angle up here. And then in order to get a vector, we actually want to multiply it by the forward direction. That gives us our move direction. We'll swap those two out. We're going to rename this to just input direction. So it's the direction that we get from our keys directly, and well, directions directly. That's not confusing at all. Okay, so we have this is all set up. So this handles rotating the model itself, and we want it to be smooth, right? So smooth rotation, but the actual walking direction, the way that we move our character is based on this target angle. So we don't want that to be smooth. We want it to be very snappy. So as we press the keys, it exactly moves in the direction that we're wanting it to go. But the model itself will kind of slowly rotate towards that direction. So these are the two separate kind of things going on here. And now let's go into Unity and click play. All right, so if I rotate this around, if I go to the left, he should be looking to the left, but he's not. But at least I can go like this. It's interesting. He like tries to look around. So something is snapping him back in place. So let's go look at our code here. We have this controller move in the move direction. What are we missing here? I'm pretty sure we want everything to be normalized. So that way the direction, it's always from 0 to 1. So that would be for the input as well as this move direction here actually. So let's normalize that. We'll save, go back over into Unity, let it do its thing. And so now, let's see. Okay, so he's still not looking in the direction that we are pointing in. So someone broke it, and it was me. Okay, well, let's take a look. What are we missing here? We have our input direction. That all looks correct. But this is not, somehow this is not working. Is our turn damper too low? Could be. Our target angle. Rotation around the y-axis. We could mess with our turn damper actually. Or, this looks kind of suspect. I want the angle, but I believe, yeah, the rotation is a quaternion, so that is not what we want there. We actually want the Euler angles, right? So we're working with the angles here. The Euler angle is not the quaternion itself, so I was using the wrong property there. Let's go back over here, click play. This should fix it now. Okay, so as I move, yep, so now he's actually turning. Guy moves fast. He is turning in the direction that I'm wanting to go with his big ass nose. All right, this is looking pretty good so far. Although it'd be nice if he would turn in the direction of the camera. So if I holding forward, but I look that way, he actually would go that way. So we'll do that next. All right, so we will need a reference to the camera in order to get some information about it. So we'll take the camera, and then what we want to do is we're trying to change our target angle here. So given our input, we want to, from the keyboard, we also want to add in the camera's own Euler angles and just the Y. So that'll put us in the right direction here. It'll be the input that we have from the keys, from the keyboard, plus the camera's look direction. And everything else should stay the same. So that is pretty straightforward. We'll let Unity load up here. We do need to make sure that we throw the camera in here. Excuse me. The player camera, which is the main camera. There we go. So we'll click play. And now, as I rotate the camera around and I press forward, he'll actually go the direction that I want him to go, so whichever way the camera's facing. So this is working splendidly. Now we need to fix this issue here. So gravity. We are missing gravity, and you can't escape that, unfortunately. And so in our case, for the update method, we actually want to always move the character with respect to gravity. And so what we're going to do is we will add in, there is a physics, gravity, and we want it to be the Y direction. And we'll always apply this at time.delta time. And we do need to multiply this Y direction by actually by a vector, because we are trying to move. So vector, we're going to multiply it by the up vector, which is just the Y axis. And so what's happening here is we are moving the character through some sort of input from the keys, but we're also always applying a downward force. So we'll save that and go back to Unity. It'll compile everything again. Let's click play. All right, so now if I walk around and I walk over these hills, I shouldn't just float off. And there you go. We've added some gravity to our player. And with gravity, of course, you know, we're going to want to add some jumping, right? So the Master Chief, he likes to jump. So we'll go back and add that right now. We have speed, turn speed. We're going to add another variable here. We're going to call this jump speed. Jump speed, and we'll just give it some value of like 7. Sure. All right, so let's see, what we want to do is, let's add in something here. So we need to check when when we're able to jump, and the character controller actually has a nice is grounded field here. And it says, was a character controller touching the ground during the last move? Well, if it's grounded, then we just don't do anything, right? So, or wait, we allow them to jump. So, so what we'll do is we'll check if there's any get key, and actually I think it's get key down or something like that. Down, get button key down, and it's space. So the space bar. And oh my goodness, I have too many of these. It's complaining at me, it's so angry with me, typical. And then what we want to do is, well, we essentially want to offset the effect of gravity. So we need to somehow add this jump speed into here. So what I'm going to do is I'm actually going to create another variable called down velocity, and this will actually take care of us. Okay, so here's how it will work. So down velocity is going to be 0, but if we press the space key, then we'll actually set it equal to the jump speed, and that'll give us some upward velocity. So then we just need to multiply this times, or excuse me, I believe we want to add it. Does that make sense? This is a float. Oh no, that's not what we want. We do want to actually add, here we go. So we'll just put it right there. So our downward velocity plus our gravity times that. And I have a feeling this is not going to work the way we want it to. So this actually does not look right. Because if you think about it, we have gravity, which is negative 9.8 meters per second, plus this down velocity. Well, if I set this down velocity to 7, to the jump speed, then 9.8 plus 7, right? So, or negative 9.8, right? So we have 2.8. It's not going to do quite what we want it to do. Because we're not changing this down velocity back, I don't believe. But hey, you know what? This is why we try things out. So let's actually see what happens in Unity. It might actually work. Since we're not grounded, it should turn it back to 0. We'll see here. So I press space. Interesting. Absolutely nothing happens. Yay. Okay, so let's go back into here and let's see what we can see. So physics plus this down velocity, if we press space, I do want to double check that there were no errors in the console. Okay, there was nothing there, so that's probably a good sign. I just want to make sure that this space was actually the right thing to use for the space bar. Let's rework this a little bit. So we'll actually set our down velocity. We definitely need to take physics into account. So let's move all this stuff out of here and put that up here. Okay, so the idea here is our down velocity, which okay, down velocity. We don't need this vector 3 dot up. there. Okay, there we go. So we do want this down velocity to be updated every frame. So even though it gets set to jump speed at some point, as it comes down here, we're actually taking out gravity over time. And so that gives us kind of the smooth, so we kind of jump up and then we have this, it's kind of a smooth jumping up and then going back down. Gives you the kind of, what is it called? The curved hyperbolic function, whatever. I don't know. I'm not a math whiz anymore. Okay, so let's double check this is going to work. We have our down velocity. This looks promising, so I think this will work. We'll actually go back onto Unity, and so it did load up some stuff. Let's see. Okay, so if I jump, oh, it just did. Okay, there we go. So I jump. Yep, and if I'm, as long as I'm grounded, I can jump. Whee! Of course, I can't like double jump, right? So I can't be in the air and then also jump again. This is good. So the only issue I'm seeing right now is that if I jump, I kind of just keep flying through the air, which definitely does not seem right. So let's go back into the code. We should probably add something like a, we will call it a drag. So drag, or you know what, let's make this a public variable, something that we can adjust. So we'll call this jump drag, and we'll just say 0.5 float. Seems good to me. So if I'm not grounded, I want to add in some drag. If I am grounded, I don't want any drag to happen at all. We will still need actually another private variable. Apply drag, or maybe it's applied drag. So if I'm grounded, we want the applied drag to be nothing. If I'm not grounded, however, we do want the applied drag to be whatever we're calling this jump drag. Okay, so taking that, now we just need to make sure that we move using this applied drag. So speed, I guess it would be a speed minus applied drag. Right, so we reduce the speed that I'm moving forward based on some drag. And we'll actually do this, so we'll do speed times jump drag. So it's like how much are we dragging away from the speed. So in this case, if we have it set to 0.5, then that means we're taking away half of the speed. You can only go half as fast when you're in the air. All right, that looks good. Let's see if it works. So if I jump, am I going as far as I was before? No, so I'm definitely slowing down. So here's my speed. And if I jump, I think I'm going slower. Let's see if I just do 1 here. Interesting, so I am getting some drag when I'm just walking here. Yeah, so I can't actually, when I jump, I just sit still. Although it's kind of weird that I get drag applied whenever I'm like barely not touching the ground. I was just like that. So the is grounded thing is kind of interesting. Doesn't seem like it works the way that I would want it to. So let's see how we can refactor this a little bit. So instead of doing subtraction, let's actually just multiply it, and then we don't have to do that here. And then the applied drag. So instead of 0, because we don't want the speed to be 0, we actually want this to be 1. So as long as you're grounded. If you're not grounded, then we'll apply this drag factor here. And we can get rid of these. All right. That actually looks okay. The grounded piece, we will have to look into that, because we still want this physics to be applied like all the time. So, you know, even if that's what we can do, so the down velocity, even if there is even if it's not grounded, we could still actually multiply it by the physics. So we had it set to 0, but actually let's just set it to like half of this y value here for gravity. And that way we still have this downward force being applied, which keeps our player on the ground until the spacebar is pressed. Because the issue we were having before is there's no downward velocity, and our player would actually experience some applied drag. All right, so let's pop back over to Unity and see how this is going to work, or not. Okay, so as I move forward, I jump, I go a little bit slower when I jump, moving forward, big jump. Yep, that looks, so this is looking pretty good. I think this will work. So in the next video, we'll actually get the Master Chief, get his character model in here, at least add some running animation, and then we'll be able to explore Blood Gulch the way it was meant to be explored, as a Spartan, just killing everything. Alright guys, well thanks for watching, and I hope this was helpful. I know there are tons of third-person controllers out there. This one is very simple, maybe not very well written, but that's okay. This is not really something that I'm going to be using that much. It's just so I can get the animations set up, all the local motion animations for the Master Chief. And then of course, we'll get into first-person controller, and things will get more complex from there on out. It is what it is. Thanks for watching, and I will see you all next time.